Mutually exclusive event probabilities are usually a little easier to calculate than ones that are not. So we're going to do a few of those first, and then in a later lesson we'll go and deal with ones that are not mutually exclusive. Take a look at this example here. It says that we have 7 marbles in a bag. 4 of them are green. So it's 7 marbles, 4 green, 2 blue, 1 red. Let me get a color this to answer a little better. Peter reaches into the bag and blindly picks out a single marble. So he picks 1 marble. The following letters refer to these events. So we're going to have 3 possibilities. Possibility A is that the marble is red. So A is red, B is that the marble is blue, and possibility C is that the marble is green. What we need to find is the probability of A happening. So the probability of A is going to be the chance that the marble he picks is red. Now there is 1 red marble out of the 7 total marbles. So the probability of A, of picking out that 1 red one out of 7, is going to be 1 out of 7, or 1/7. So the probability will be 1/7. Now the probability of B, the probability of just picking out a blue marble out of the bag, well, there's 2 blue marbles. So it's going to be the probability of B is 2 out of 7. Now the probability of C, how many times what his chances of getting a green marble are? Well, there's 4 green marbles. So his chances are going to be highest of getting a green one, obviously. So the probability of green, of C, is going to be 4 out of 7. 4/7. Now the probability that it's going to be B or A, that he's going to pick either a blue or a red. Now what we're looking at here is the combined probability of A and B, because the chances of it being one or the other really includes the chances of either one of them happening. So we have 1 out of 7 and we have 2 out of 7. So we have a total of 3 out of 7 chances of getting either B or A. So 3/7 is the probability of B or A. Now the probability of C or A would be probability of C and the probability of A together, because the chances of either one include both. So we'll have 1/7 plus 4/7 equals 5/7 is the probability of C or A. Probability of Cora. The probability of A, B, or C, well, this one's easy because there's only 3 possibilities. A, B, and C are all the probabilities we have. So the probability of A, B, or C is just going to be 1. It's going to be 100%. Because if he's picking a marble, he has to pick one that's green or blue or red. Those are the only colors that there are. The last one is the probability of A and C. Now this one could be a little difficult, but really it's just a kind of a brain teaser for you, because really it's saying here that he's picking 2 things at the same time. So either we'd have to have a marble that was red and green, or he'd have to pick 2 marbles, and he's only picking 1. So the probability of him picking this one is 0%. It's 0 out of 7. There aren't any marbles that are both red and green, and he's only picking 1, so this just can't happen.